So in the last video we were discussing about the Lennard-Jones potential, and which is useful for describing the interaction between two molecules or two atoms which have almost no charge. So what are the systems we can take? We can use Lennard-Jones potentials to describe their potentials or how they are interacting. Some of the examples are H2, argon, noble gases you can take. So I thought let me just make a video on what are intermolecular forces. So intermolecular forces are also known as intermolecular interactions. They are electrostatic forces of attraction between molecules by which they get stabilized and make a stable compounds. So it is that simple. So it's an example of a AB molecule which in which A is less positive electronegative and B is more electronegative. So there will be a formation of partial positive charges and partial negative charges. So this creates a charge separation, you can say, and that's why there is a attraction between different molecules, and so this is how molecules will be attached or in a compound. So now the first example is dipole-dipole forces. So dipole-dipole forces arises when there is a charge separation or there is a permanent dipole moment. As you have learned in your 12th standard or 10th standard might be that, or in graduation masters also, they like molecule like water and acetone, they have permanent dipole moment. So it means that there is a separation of positive and negative charge. So deliberately I have just make it positive and negative, just to show this electron density is more shifted towards the negative charge, and it is so suppose if this system have to attract another system, then it should be a partial positive and partial negative. So there will be a forces of attraction. So some of the examples are acetone, hydrogen sulfides, difluoromethanes, chloroform, hydrogen cyanides, and phosphine. So let me just give you an example. This is an acetone molecule. So as carbon is electropositive and it is oxygen is electronegative, so there will be a dipole moment from positive to negative charge, and similarly in another molecule there will be a separation, there will be a positive and negative charge separation. So definitely the positive ends of a one this carbon attract the negative end of this oxygen, there will be a there will be a forces of interaction, because this is a we are talking in terms of positive and negative charge. So that is why they are called electrostatic forces of interaction. So similarly there is means more example, you can say H2O dimer. So this is a good example of dipole-dipole forces. This is also called hydrogen bonding, because there is a formation of if there is a partial positive and partial negative charges, then definitely there will be a one hydrogen which is attracted to oxygen, so there will be a formation of hydrogen bonding. So there is one more example which is called, so previous example is an intermolecular hydrogen bonding, like two different molecules are connected by electrostatic forces or dipole forces. But in some cases there is a positive and negative ends are present within the one molecule, so they can get easily attracted, and examples are orthonitrophenols and salicylic aldehyde. So yeah, this I think orthonitrophenol, it is not a phenol, but I hope you understand. But let me just make it one clear thing. So this is just a means just to show it is a proper benzene. So I will just do make it very clear. uh, this is a proper benzene molecule, and just for sake of simplicity I am just showing it by like there it's in standard convention. So it's actually a benzene molecule. So now London forces or induced dipole forces of attraction. So suppose you have H2 gas. So is it possible that H2 gas can have any kind of dipole forces? It is very unusual to see, like suppose if there is no forces of attraction between two H2O molecules in gases, then you cannot liquefy H2 gas. This is impossible. Suppose if there is no forces of interaction between H2 molecule, then you cannot liquefy H2 gas. Is it so? No. We can liquefy gas. Requires high pressure and very low temperature. So what is going to happen in this kind of system? Uh, Example, H2 argons, noble gases. So I am just taking the H2 just for convention. I am showing that there is a 2 positive charge and 2 negative charge. So for some time there will be a no there is a spherical distribution of charges. Yeah, electrons are moving, and then just because of this electron movement they tends to just change their shape, and then there is a formation of a like elliptical distribution of charges. And because there is a elliptical distribution, so now there is a chances that H2 molecule can interact. So but because these forces are very weak, so we tends to uh, uh, call them induced dipole moment, because they are not initially present, but they happen because of the asymmetry of the charge distribution. So this is a with this concept we can say the hydrogen gas is a gas at normal temperature and pressure, but hydrogen condenses to a liquid at minus 43 degrees or 253 degrees. You can just check it on Google. So now there is one information I have used, so I am just giving credit to author. So these are like sigma and epsilon that we have discussed in previous class. uh, that sigma and epsilon are the two parameters. Sigma is a bond strength and epsilon is a sigma is a van der Waals radii and epsilon is a bond strength. So it is very easy to see now the systems that we are considering, they generally don't have any kind of permanent dipole moments, or some dipole moments they have, but yes, definitely I am just taking these examples to show they means for doing calculations on these kind of system you require uh, parameters, sigma parameters. So I hope this is clear. Yeah. So I was now, as LJ potentials don't have any concept of charges, so how can we like deal with these kind of problems? So yes, there are some potentials which we can use to describe their interaction. So one of the model which is for water, it is called SPCE water model. So SPCE is a uh, it's a water model, just because it's information class, so I will not discuss widely, but it is a 3-side rigid water molecule with charges with Lennard-Jones potential parameters. So there are charges. So when there is a like system which having a positive and negative charges, or there is a permanent dipole moment, then we can't just use Lennard-Jones potentials, or their Lennard-Jones potential should be calculated using the first principle based calculations. So I hope this much is clear, and thanks for watching our videos, and please like and subscribe our channel.